In today's lesson, we're going to look at inequality word problems. Our last lesson focused on equation word problems, and reading through our problems, there was a key word of is that let us realize that we were working with an equation. For example, 5 plus 4 times a number is 16. I know it equals 16. Or in a word problem, if they bought something and the total is $15, I know it's going to equal $15. So that word is helped me realize that I was working with an equation. With inequalities, there are a bunch of different words that we have to look at. One set of words that we're going to look at is at least. Okay, so in question A, it says, if you wanted to make at least $10, what does this mean? List possible dollar amounts that we would be happy making. Okay, so if we want to make at least $10, well, we would be happy with making $10. We would also be happy with $11 or $12 or $13 or $14, etc. Okay, $10 or more we would be happy making. If you wanted to get at least an 85% on your vocab quiz, what does this mean? What scores would you be happy with? Well, if we wanted at least an 85, we would be happy with an 85%, or we'd be happy with an 86, or an 87, or an 88, etc., all the way up to 100%. Those are the grades we would be happy getting on our quiz. So we would be happy with getting 85 or above. So the symbol, the inequality symbol that we would use for at least is going to be greater than or equal to. Okay, in each example, we could be equal to the number where it said at least, but then we also would be happy with values that were bigger than that value. So at least is going to use the symbol greater than or equal to. All right, so in our example underneath, Hannah is paid $150 a week plus a commission of $40 on each computer that she sells. How many computers must Hannah sell in order to make at least $350 a week? Okay, so step one, we're going to define our variable. Let n equal. The question asks how many computers. So n is going to equal the number of computers. Okay, step two, setting up our problem now. She gets paid $150 a week plus the commission of $40 on each computer. So she's going to make $150 no matter what, plus her commission of $40 on each computer, and n is the number of computers. So we'll do 40 times n. And this time we want her pay to be at least $350. At least uses the symbol greater than or equal, and then the total was $350. So there's our inequality. 150 plus 40n is greater than or equal to 350. Let's solve this now by subtracting 150 from each side. 40n is going to be greater than or equal to 200. And now if we divide each side by 40, okay, we're going to get n is greater than or equal to 5. There's step number 3. We've solved the inequality. Notice we've preserved the symbol because we divided by a positive number. Now let's do step 4, which is going to be the check. Okay, rewrite the inequality. This said 150 plus 40n is greater than or equal to 350. Now, I'm not going to use 5 in my check because if I use 5 in here, at the end it's going to say 350 is greater than or equal to 350, which is true. 350 is equal to 350, but I won't know if I've used the correct symbol, okay? I want to make sure that my answer is going to be greater than or equal to 350. So coming over here, I'm going to use a number that is greater than 5. So let's use 6 as our number of computers. 150 plus 40 times 6 is greater than or equal to 350. Again, I'm using a number that's bigger than 5, so I make sure that I've used the correct symbol of greater than or equal to. When I do the order of operations, I'm going to multiply first. 40 times 6 is 240, so we're going to have 150 plus 240 is greater than or equal to 350. Adding 150 and 240, that's going to give me 390, which is greater than or equal to 350. So the check works. I now know that I've used the correct symbol. And now I'm ready to write my sentence here in step 5. Hannah must sell at least, because those were the words that they used right here, Hannah must sell at least, and then coming back to step 3, 5 computers. Hannah must sell at least 5 computers. In our last example, we saw that the words at least meant greater than or equal to. What if we have the words at most? If you wanted to spend at most $40 on a game, what does this mean? List possible dollar amounts that you would be happy paying. Well, if I wanted to spend at most $40, I would be happy paying exactly $40, but I would be also happy paying $39 or $38 or $37, all the way down to maybe $1, or maybe I can spend $0 and get the game for free. All right, I'd be happy paying $40 or less. If you wanted to have at most 4 people over for dinner, what does this mean? List the possibilities. Okay, so we would be happy having 4 people over, or 3 people, or 2 people, or 1 person, or maybe even 0 people. Not much of a party, but that would work here. 4 or less people coming to the party. So for the inequality symbol for at most, well, again, we would be happy being equal to the number that we were looking for, but we would also be happy with any number that was less than that value. So we would use the symbol less than or equal to for the words at most. In example 8, they tell us that Nick rented a car for $175 a week plus 50 cents a mile. How far can he drive if he wants to spend at most $250? So step 1, we're going to define our variable, let n equal. They want to know how far can he drive, and we're measuring that here in miles. So let n equal the number of miles. Step 2, let's set up the problem. Nick rented a car for $175 a week plus 50 cents a mile. $175 a week plus 50 cents per mile, which is n, so 50 cents times n. And now Nick wants to spend at most $250. At most means less than or equal to $250. So there's our inequality. Let's go ahead and solve it now. We'll subtract 175 from each side. Okay, when we do that, we get the inequality now 50 cents n is less than or equal to 75. Now we'll divide each side by the 50 cents. And that's going to give us an inequality of n is less than or equal to 150. There's our solved answer. N is less than or equal to 150. Step 4 now, let's go ahead and do a check. The inequality said 175 plus 50 cents times n is less than or equal to 250. And again, I'm not going to use 150 for my answer, for my check, because again, I would get 250 is less than or equal to 250, which is true, but I still don't know if my symbol is pointing the correct way. So I'm going to come back down here. I'm going to use a number that's less than 150. Let's use 149. 175 plus 50 cents times 149 is less than or equal to 250. If I've done this correctly, I should get a number now that's going to be less than 250. So let's multiply first 50 cents times 149. I'm going to have 175 plus, that's going to give me 74 and 50 hundredths, or $74.50 is less than or equal to 250. Now when I add 175 with 74.50, that's going to give me 249 and 50 hundredths, so $249.50, which is less than or equal to 250. So my check works. Now I'll write my final statement here. Step number 5. Nick can drive at most, and then over here, 150 miles. Nick can drive at most 150 miles. So we've seen the words at least and at most represent inequalities, and there are some other words that represent inequalities as well, and those would be maximum and minimum. Okay, the word maximum, I like to think about it in the context of a test. The maximum score that you can get on a test is a 100, which means that you can get exactly a 100 or you can get less than a 100. So the word maximum is going to be the inequality symbol less than or equal to. The minimum score that you need in order to pass a test is a 65. So when you take a test, you always want to get a 65 or higher in order to pass it. So minimum is going to be greater than or equal to. Okay, so keep this in mind as you read through your word problems. An example number 9, it says that an amusement park charges $6 for admission and 76 cents for each ride. If you have $20, what is the maximum number of rides that you can go on? So let's define our variable in step 1. Let n equal, what is the maximum number of rides you can go on? Let n equal the number of rides. That's what we want to try to figure out. Step 2, let's set up the problem now. The park charges $6 for admission and 76 cents for each ride. $6 for admission plus 76 cents for each ride, which was n, so we'll multiply that by n. Now, if you have $20, what is the maximum number of rides you can go on? Okay, maximum means less than or equal to. We can't go over $20, so this has to be less than or equal to the $20 that we have. So there's our inequality. Let's go ahead and solve it now. We'll start by subtracting 6 on each side. When we do that, we get 76 cents n is less than or equal to 14. Now we'll go ahead and divide each side by 76 cents. On the left, 76n divided by 76 cents is n. Dividing by a positive will preserve the symbol less than or equal to. And now we'll use our calculator and we will type in 14 divided by 76 hundredths equals, and notice that decimal. We're going to write out the full calculator display. So I'm going to have 18 and 42105263. And this is my solved inequality. There it is in step 3. Step 4, now we're going to do a check. Rewrite the inequality. 6 plus 76 hundredths n is less than or equal to 20. Now, it's not possible to go on this number of rides, so we're going to pick a number that is less than that number. Why don't we just use 18? 18 is less than or equal to that number right there. So let's use 18 in our check. 6 plus 76 cents times 18 is less than or equal to 20. We'll start by multiplying the 76 cents by 18. 6 plus, and then that multiplication problem gives us 13 and 68 hundredths. And hopefully we're less than or equal to 20. 6 plus 13 and 68 hundredths is 19 and 68 hundredths, which is less than or equal to 20. So the check works. And now step 5, we'll write our sentence. Now, we can't go on this number of rides, but we can go on a maximum we just saw right here of 18 rides, okay? You can go on a maximum of 18 rides. Okay, that would spend a total of $19.68, which is less than or equal to the $20 that we have. In example 10, they tell us that Matt works as a carpenter. He was paid $65 today for supplies, and he's paid $25 per hour. Matt would like to earn a minimum of $225 today. How many full hours will he need to work today? So let's define our variable in step number 1. Let n equal. How many full hours will he need to work? The number of hours is what we're looking for. N represents our number of hours. Let's set up the problem in step 2. Matt gets paid $65 today for the supplies, and he gets paid $25 per hour. $65 for supplies plus $25 times n, which was our number of hours. Matt wants his pay to be a minimum of $225. Minimum means greater than or equal to. Matt wants to earn $225 or more. So there's our inequality. We'll solve it by subtracting 65 from each side. That'll give us a new inequality that says 25n is greater than or equal to 160. And now what we need to do is divide each side by 25. So let's go ahead and do that. On the left, 25n divided by 25 is n. Dividing by a positive preserves the symbol, greater than or equal to. And when you type in 160 divided by 25, that gives you a decimal of 6 4/10. N is greater than or equal to 6 4/10. There's our step number 3. Step 4, let's go ahead and do a check. Okay, we had 65 plus 25n is greater than or equal to 225. Now, notice that our answer here was a decimal, all right? Matt's boss isn't going to let him work partial hours, so I can't use 6 4/10. I'm going to need something that is greater than 6 4/10. 6 isn't going to work. 6 is not greater than or equal to 6 4/10, but 7 is. So let's go ahead and use 7 in our check. 65 plus 25 times 7 needs to be greater than or equal to 225. We'll go ahead and multiply first. All right, so we're going to have 65 plus 25 times 7 is 175, is greater than 225. And then we're going to go ahead and add 65, which gives us 240, which is greater than or equal to 225. So the check works. And now we'll write our sentence here. Now again, Matt can't work partial hours, so we just use 7, which is the first number, the first whole number that is greater than 6 4/10. So we will say that Matt needs to work a minimum of 7 hours. Matt's going to need to work a minimum of 7 hours so that he can make at least $225 today.